Hello class, today we're going to go ahead and look at section 12.4 and 12.5, multiplying and adding probabilities. So we're going to look at, to find the probability of spinning a purple and then spinning a blue, you need to find the probabilities of both events occurring separately. So spinning a purple and then spinning a blue, since they're on two different spinners, they would be considered independent events, because spinning one spinner has no effect on spinning the other spinner. So looking at this one, I would look, well, I want to find the probability of purple. And I recommend on your note sheet, since it didn't show up very well, kind of labeling like this is purple, yellow, green over here, so you know when you look back. So if I look at the one for purple, how many sections is this broken up to? 1, 2, 3, 4, 5, 6, and 1 out of those 6 is purple, so 1/6. Then to be blue, I look at my other spinner. It's broken into 4 sections, and 3 of those 4 are blue, so the probability of a blue is 3 out of 4. So independent events, just a reminder, it's the result of one event, has no impact of another event. So an example, rolling a die, then drawing a card from a standard deck. They do not have any association, so one does not affect the other. So in order to find the probability of independent events, what you need to do is find the probability of both events occurring, okay? And then, it's an and statement, and I've already talked about this, you multiply the two together, okay? So what we do is we would once again find the probability of purple, which we did on the other slide. It's 1/6. Probability of blue was 3/4. Now if I want to find the probability of being purple and blue, well, being purple is 1/6 and is multiplying, so, and blue is 3/4. Now just a little reminder, when we multiply fractions, we just go straight across. So I take 1 times 3 is 3, multiply your numerators, and then multiply your denominators. 6 times 4 is 24. So I have 3 over 24, which reduces to 1/8. You could also put it as a decimal if you'd like. So that's independent events. We're also going to talk about mutually exclusive events. So the two events that cannot happen at the same time, that makes them mutually exclusive. So one thing is, an example would be drawing an ace or drawing a 2 from a standard deck of cards, because you cannot be an ace and a 2 at the same time. Okay, here's an example that would not be mutually exclusive. If I drew a heart and an ace, those two things could happen at the same time because you could be the ace of hearts, so they are not mutually exclusive. In order to figure out the probability of mutually exclusive events, okay, you would find the probability of each, and then you would go ahead and add them. Mutually exclusive says I'm going to be I'm going to be blue or I'm going to be purple, okay, one or the other, not both. So once again, I use my probability of purple, which we found before, 1/6, and the probability of blue is 3/4. And now, or, so it would be 1/6 plus 3/4. Now, in order to add fractions, you need to get a common denominator. So for this one, I would multiply by 2/2 to get my denominator to 12. And if I want to get this to 12, I would multiply by 3/3. So I would get plus 9/12. And then when you're adding fractions, remember you only add the numerator. So it's 2 plus 9, which is 11 out of 12. So that's the probability of being purple or blue. So here's some examples of an independent event. Julio reaches into an ice-filled cooler containing 8 regular soft drinks and 5 diet soft drinks. He removes a can, then decides he is not really thirsty and puts it back. Okay, well, since he put it back, it's independent. Okay, what's the probability that Joe and the next person to reach into the cooler both randomly select a regular soft drink? Well, since he puts it back, okay, it's an independent event, and we are trying to figure out the probability of having a regular soda and then getting another regular soda. So regular and a regular. So what I would do is say, well, to get a regular soft drink, well, there's 8 regular and there's 5 diet for a total of 13. And there are 8 regular, so it's 8 out of 13. And, so multiply by, to get another regular would be 8 out of 13 again, because it's one after the other. So 8 times 8 is 64. 13 times 13 is 169. And if you were going to go ahead and divide those, you get 0.379. I will take either fraction or decimal form as long as it is the reduced fraction. Another example of an independent event. In a state lottery game, each of the 3 cages contains 10 balls. The balls are each labeled with one of the digits 0 through 9. What is the probability that the first 2 balls drawn will be even, and, so keyword, that the third will be prime? So remember, and is multiply. So something to keep in mind. And these are independent events because I have 3 cages and they each contain 10 balls. So what I get from the first cage does not affect what I get from the second cage. So I want to get the first 2 balls to be even. So I'm going to find the probability of being even, and then even again, and then prime. Okay, so well, to be even, the numbers 0 through 9, well, how many of them are prime? I would count. There's 0, 2, 4, 6, 8. So there's 5 out of 10 times, to be even again, it'd be 5 out of 10 times to be prime. Well, now to be prime, remember, that's you're only divisible by yourself and 1. So it would be 2, 3, 5, and 7 in between 0 and 9. So there's 4 out of 10 of those. So you could just go ahead and multiply these numerators across. I'd have 5 times 5 is 25 times 4 would give me 100. All over 10 times 10 times 10 will give me 1,000. And if I were to simplify this, those will simplify. So I have 1 over 10, and there would be my solution. Example 3. 1 teacher must be chosen to supervise a senior class fundraiser. There are 12 math teachers, 9 language arts teachers, 8 social studies teachers, and 10 science teachers. So let's just go ahead first and figure out how many teachers total there are. 12 math, 9 language arts, 8 social studies, and 10 science. So that means there's 39 total. Okay, so picking off where I left off right here. If the teacher is chosen at random, what is the probability that the teacher is either a language arts teacher or a social studies teacher? Okay, so you want to do the probability of being a language arts teacher or a social studies teacher. Well, to be a language arts teacher, how many language arts teachers are there? There are 9 out of our total, 39. Okay, this is mutually exclusive because you cannot be a language arts teacher and a social studies teacher. So mutually exclusive, cannot be both. And so since it is, and it has the word or, I know I'm going to add. Now I figure out the probability of being a social studies teacher. There are 8 social studies teachers out of 39. Once again, remember with fractions, when you add, you only add the numerator. So 9 plus 8 is 17 out of 39. If you wanted to calculate this on your calculator, it would be 0.436. All right, example 4. There are 7 girls and 6 boys on the junior class homecoming committee. A subcommittee of 4 people is being chosen at random to decide the theme of the class float. What is the probability that the subcommittee will have at least 2 girls? Okay, at least 2 girls. Well, the probability of at least 2 girls means that there can be a probability, you got to figure out the probability of having 2 girls, or, so or is plus, or the committee could have 3 girls, or the committee could have 4, because it's up to a committee of 4, and we're starting with at least 2. So it means it could be 2 or 3 or 4. So we need to go ahead and figure out the probability of each one of these. So let's go ahead and start doing that. So I need to think I am choosing a group of people. So this would be a combination because order does not matter, it's just a group. And I would figure out how many people total I have. 7 plus 6 means there's 13 total people. Okay? So I'm selecting a committee. And I know that I'm going to have 2 girls. Well, that means I have to select 2 from the 7. So I would have 7 C2 times Okay, now I have to think how many boys would be on a committee. It's a committee of 4, and if I have 2 girls, that means there's going to be 2 boys. Well, there's 6 boys to choose from, and I'm selecting 2 of them. Over the total, well, there's 13, and we are selecting 4, a committee of 4. Right here, this is the probability of 2 girls. Now we have to go ahead and figure out the probability of 3 girls. So I have my group of 7 girls, and I'm selecting 3 of them, and that means there's 6 boys, and I'm only selecting 1 all over my total options. 13 people total, selecting a group of 4. This is my probability of having 3 girls. Now I need to go ahead and figure out the probability of having 4 girls. So it would be 7C4, and I'm not selecting any boys, so I'm not worried about it. So I'm not worried about incorporating them. And so here would be my probability of 4 girls. Now I'm going to go ahead and simplify a little bit. 7C2, when you calculate that, you should get 21 times 6C2, you should get 15. All over 13C4 is 715, plus 7C3 gives you 35, times 6C1 gives you 6, all over, once again, 715. Plus, if you figure out 7C4, that gives you 35, all over 715. Now I'm going to go ahead and simplify again. I would take 21 times 15, which gives me 315 over 715, plus 35 times 6 gives me 210 over 715, plus 35 over 715. Now I go ahead and add up my numerators. 315 plus 210 plus 35. When I go and add them all together, I would get 560 over my total, 715. And if I reduce this, I would get a fraction of 112 over 143. And if you go ahead and divide it on your calculator, you get 0.783. This is my probability of having at least 2 girls on the committee. We're going to go ahead and stop the video here for today. We're going to do dependent events and inclusive events on the second video. So go ahead, stop the video, and have a nice day.